Hello and welcome to our webinar, The 3 Best Practices You Need to On-Ramp to the Cloud. My name is Samantha Kelly and I'll be moderating today's webinar. I'm joined here today by Boris Volanov, VP of Technology at NuoDB, and Wissam Zaran, Principal Consultant at Temenos. In this webinar, Boris and Wissam will review the best practices for pacing cloud adoption so you can move banking applications to the cloud on your own timeline, selecting cloud-native, cloud-agnostic banking solutions that help you deliver on customer demands, and choosing a relational database that supports modern architectures. At the end of the webinar today, we'll open up for some Q&A. Before we begin, I'd like to review a few final logistics. Our webinar will last around 45 minutes. The webinar will be recorded and the video and slides will be made available for replay. Attendees will be muted during the call. However, you may submit questions at any time during the presentation using the questions panel in the GoToWebinar control. So with that, I'll turn it over to Boris.
Thank you very much, Samantha. Again, my name is Boris Volanov. Let me start by, first of all, welcoming everything to the session and thanking you all for taking time to spend this time with us. First of all, Wissam, maybe you can introduce yourself, your background, so we can have who are the speakers here.
Hi, yeah, my name is Wissam Zaran. I work at Temenos. I've been there for about 20 years now, mainly on the technology side of things. I'm very excited to be here to present with NuoDB and how we can help our clients succeed.
Fantastic. Thank you very much. My background, Sam said, I'm VP of Technology at NuoDB. My primary task is to work with customers and banks and other organizations around the world, as well as other technology partners. The things I like the most are benchmarking, performance at scale, and architecture of complex systems. So in today's session, Wissam and I will share with you our experiences as we're dealing with all these different organizations around the world, our experiences of how banks are moving towards the public cloud. We will talk about a concept which is called cloud native. This is a concept which is commonly used in our industry, and I'm sure most of you on a phone are familiar with it. What we'll do is we'll define the term from the perspective that we see it. We'll make it in very simple terms, and then we'll show you how our respective products, it's a banking platform from Temenos and a distributed database from NuoDB, how those two products together make up a cloud-native solution. And then towards the end of this session, we'll talk about two customers, which utilize this cloud-native capabilities to really differentiate themselves in the marketplace in a reasonably unique way. And I'm sure you're gonna both find it interesting and enjoyable. So with that, let's jump into the session. We wanted to start by stepping back and really, first of all, agreeing on the couple of facts in terms of what makes banks to be interested in moving towards public cloud. What is the opportunity? What are the benefits? And in the industry, again, there are many different models and approaches that are taken to describe it. What we've done here is we've took a very respectable organization, British Banking Association, and we use their model, which is very simple, to describe the benefits. What are the benefits and opportunities of moving towards the public cloud for the banks? And the opportunities are quite straightforward. You have sort of like 3 buckets, if you will. The first bucket on the left is by far the most important. That is something that they call Agile innovation. And we all understand this. This is truly about creating a very compelling user experience. It's about rolling out a lot of functionality and new capabilities and practicing innovative approaches in terms of what customers want to see, what kind of capability they want in terms of, maybe just to give an example, real-time payments, currency exchanges. There's a number of neobanks, challenger banks, digital banks, a variety of organizations which are pursuing this kind of very rapid experimentation and delivering competitive user experience in order to attract the the new users to the bank. So this notion of innovation is critical for the next phase of evolution in the banking space. Then we see on the right side something that they refer to as cost benefits, and this is also could be well understood, if you will. Public cloud infrastructure is an example of what in today's world we would call a shared economy, if you will. Somewhat similar to what Uber does to car utilization, right? Public cloud does to improving efficiency and capacity of what you can do in terms of utilizing infrastructure for your banking needs. In today's world, as you know, the software needs to be licensed, the infrastructure needs to be procured, and usually those types of investments are oversized, if you will, to ensure that capacity is available in your data center, and that is very expensive. You essentially pre-buy future capacity upfront. Cloud is very different. Public cloud allows you to use things as you consume them, and the capacity is infinite. Therefore, if you require either some sort of peak in capacity, for instance, for close of business processing or something else, public cloud easily accommodates that. And then lastly, on the bottom, we have a bubble for risk mitigation, right? That also is reasonably easy to understand and relate to. If today's processes are very much custom and operated by people who are specialists in your particular shop and they know how to operate the systems, the public cloud provides ability to really rely on deep automation, if you will, right, of all the processes. And it also applies economies of scale, right? You're not tied to a particular single implementation. The public cloud operates hundreds and thousands of instances of computers and databases, and therefore they're very good at that. So the overall risk is, in a lot of respects, is much lower. Security is great, but at the same time, clearly there are different dynamics in terms of how risk needs to be mitigated, and we'll talk a little bit about this later on. So these are on a very high level. The reason we're doing this is just to set up the ground rules, if you will, and engagement. So these are the opportunities that banks may and are really embracing and leveraging as they move their core systems, payment systems, core banking systems, and others towards public cloud. An opportunity is huge, and everybody's doing it. We actually, between Wissam and I, we have a chance to observe how different geographies adapt this kind of transition to public cloud in very different ways. Asia Pac, for instance, is very aggressive. Regulators are promoting all kinds of competition between the banks. They're issuing licenses, and therefore Asia Pac is quite further ahead the rest of organizations across the globe. Europe is very active. UK is very active in this space. A number of neobanks are emerging. US is a little bit behind in terms of adoption of public cloud technology for core banking systems, but nevertheless, they're moving towards that very rapidly as well. So why is this important is because this concept that I've mentioned, cloud native, has direct implication to what we just discussed here. In order to be able to take advantage of these opportunities and benefits, the infrastructure that you work with needs to adopt cloud native patterns, and it needs to move towards very specific things which are sort of foundational aspects of being cloud native. So this is a very simple diagram, and sometimes, again, another term that I'm sure you've heard many times in the last number of years, the digital transformation. So the digital transformation is really a process of moving from traditional approaches and systems that you see on the left side of this diagram, right? Things like custom hardware and enterprise IT approaches and monolithic applications and databases, towards what we would call cloud native. So if you can look at the right side pretty much captures the essence of what cloud native is, right? And we normally talk about several aspects of this, and we sometimes refer to that as people, process, and technology. So you can see that cloud native really impacts multiple aspects of how the software is developed, how it's evolved, what kind of infrastructure it runs in, and the entire life cycle of how the software behaves. right? So what's very important is, for instance, DevOps allows you to really streamline the process of deploying the software and changes. There are notions that you may have heard of, such as continuous deployment and continuous integration. That's what DevOps enables. The applications need to adapt the container-centric architecture with microservices. We'll hear from Wissam a little bit later on. That's one of the examples of how Temenos infrastructure for core banking embraces this kind of concepts. And lastly, also what's very important is to have a distributed database, because it enables the entire system to be able to natively take advantage of the benefits that cloud provides. Now, also what's quite important to mention in this slide, that there are roughly, if we look at the spectrum of different ways to move your existing applications to public cloud, there are two sort of opposing approaches that emerge and that banks around the globe embrace. One of them is called lift and shift. And in this approach, effectively you take the stack on the left side and you make it run in the public cloud. While this is a relatively straightforward process, it doesn't require a lot of investment. The outcome of this approach is quite simple. It doesn't really it doesn't necessarily result in any kind of benefits that public cloud provides to the bank, right? Because you're effectively running the same type of infrastructure in the cloud. The second approach is cloud native, and cloud native is that stack that we have on the right side. That's what applications to be able to embrace to move to the public cloud. But always consider that these are two opposing approaches, lift and shift and cloud native. And normally you take either one, or banks take either one of those two approaches to move forward. Another interesting and important aspect of what we're talking about, cloud native, is that cloud native doesn't imply that the applications and infrastructure really need to actually execute in the cloud environment, in a public cloud environment. Quite opposite. Cloud native implies that the applications can run anywhere. And as a matter of fact, this is really the theme for today's conversation, is that a lot of customers that we work with, they start by adapting cloud native architecture for on-prem deployment, right? So once you adopt the cloud native architecture, you have flexibility of how and when you deploy your applications in what environment. You start on-prem if you wanted to. For instance, in the US, that is a very common approach, because regulators put a lot of challenges in terms of licensing and security and privacy that prevent banks from moving to the public cloud today with their core banking systems. So the cloud native architectures can be adapted for on-prem platforms. But then over time, these applications can move towards a cloud. So here on this picture, we see the sort of your natural cloud deployment, where cloud native architecture, the platform can be moving towards the cloud and can be deployed in the cloud. And then as another approach, as time goes by, what we see is emerging is something that people call multi-cloud deployment. And we'll show an example of that. But that is a deployment where a bank can actually be deployed across two multiple cloud providers. So we'll show an example where a bank in Asia is running across two clouds, across Google compute platform and Amazon, right? So GCP and AWS are the two different cloud providers that the bank is relying on, and we'll dive into this particular implementation in a minute. But again, the very important point that cloud native really implies run anywhere, and that is very critical. So now we get to where we started the first slide. So what are the best practices in terms of moving existing banking applications to the cloud, to the public cloud? And as we mentioned, cloud native is really the mechanism to do that. But the natural question that comes up, well, it sounds like the process of development and operating this infrastructure is really different, radically different from where a lot of organizations find themselves today, right? So processes are different, skills are different, technologies are different. It will take a long time to actually succeed in moving one's operations towards the public cloud. And that is absolutely the case. And therefore, this is really the impetus for this conversation, that our recommendation and that what we see is happening around the globe is, rather than develop all of this expertise internally and have a long and risky journey towards public cloud, what people are often do is they embrace off-the-shelf solutions which address their core banking problems out of the box, and they then can be deployed either on-prem or in a cloud, or they can actually be consumed as a service. And Wissam in a minute will share with us stories and descriptions of Temenos Temenos core banking platform, which is very, very powerful. So in terms of the best practices are very straightforward, right? We'll recommend that you start by researching and finding the best cloud-native banking solution that can be deployed in a variety of different form factors. That's step number one. Step number two is you have to be able to complement that core banking solution with a distributed database. And the reason for that is quite simple. Database is a foundation of the banking system. And unless database is cloud native, unless it can take advantage of underlying platform, the entire solution will not be able to benefit from all the opportunities that public cloud provides. And the last point, which is critical, right? You have to be able to move through this process of becoming cloud native on your own timeline, right? So ability to start making incremental steps towards the journey is absolutely critical. And we'll share with you a couple of examples where you see that you can start today with this stack, with this system, but you can start on-prem and start moving towards public cloud incrementally over time as you need to. So with that, let me pass the conversation to Wissam, who's going to share with us the interesting details about Temenos banking platform in all of its glory. Wissam?
Thank you, Boris. So let me just introduce you about Temenos and what we do. We offer cloud-native, cloud-agnostic, API-first digital banking for core banking, payments, risk and compliance, and data lake and analytics. Our product set is fully decoupled, allowing banks to deploy each product standalone so they can renovate their technology where needed. Temenos has always produced software according to a set of principles. We believe in reuse, openness, being agnostic about technology platforms, which is key here. And this means that everything that we do, all the developments that we make, are available to our clients. It also means we give our clients choice over what technology that they run, and we never lock them into a particular provider. This openness means that third parties can develop on our platform to accelerate innovation, ensuring that our clients always have access to the best technology and functionality. The model bank strategy is to provide reusable artifacts that are country or region specific that significantly reduces the implementation effort. So basically our mission is to provide financial institutions of any size, anywhere in the world, the software basically to thrive in a digital banking age. And we do this by building, delivering, and supporting the world's best packaged, continuously upgradable end-to-end banking software, which is both cloud native and cloud agnostic. So we use design-led thinking throughout to orchestrate all of our customer touch points to create a frictionless customer journey. And you can take our software and consume it as a SaaS service like Temenos. You can deploy it on all of the main hyperscale cloud platforms, or have a hybrid model, or even put it into your own cloud-like data centers. If we go to the next slide. So, and Temenos has been on a journey itself. So we've evolved over a long period of time, and we've seen, lots of technology trends that have come about And we've basically aggressively adopted many of those trends, including, I'll give you some examples, XML, service-oriented architecture, event-driven architecture, code generation, model-driven design, RESTful APIs, and cloud. And we've had major technology evolutions, including architecting the platform environment from Unix to Java. Now we've moved that from Java to be using container technology, achieving cloud native and cloud agnostic. Our products can, as I said before, to be deployed on major hyperscale public cloud platforms, Azure, AWS, GCP, but also on private cloud platforms such as IBM, Oracle, or your own infrastructure. So the cloud native architecture really does provide us elastic on-demand scalability, minimizing compute resources, providing a highly efficient deployment model. That's how you use the cloud platform as efficiently as possible. We no longer want to size for the maximum workload and have all of those resources just sitting there just in case a peak a workload comes in. So we want to elastically scale, elastically utilize underlying resources when we need them, and crucially pay for them only when we need them. So Temenos is a technology company. We focus on delivering banking software, and we've got a proven track record in this industry. We're constantly searching for the best technology for our customers, and priority is given to those that will benefit the most. We now fully support distributed databases to scale up and down. It has to be naturally resilient with multiple copies of the data that is always active. This basically allows us to remain cloud agnostic and to give our clients more choice. Thank you.
Wissam, thank you very much. This is great. I have actually, if we can go back a slide. What's fascinating for me in a Temenos platform is this separation between transaction processing and user experience. Maybe you can spend a minute sort of like frame this in a context of, like we've talked about, that one of the drivers for public cloud adoption is this notion of user experience and how you can customize it, how it can be very agile and so forth. Can you spend a minute maybe putting a little bit more color on this, separating front office from the back end operation? That would be great.
Yes, sure. So what we've done, we've decoupled what we're terming our enterprise services from our distribution services. So we've got manufacturing services back in Transact, serving up the banking capability and the functional, product set, etc. But we've completely decoupled that from our digital banking space, which is all about user experience and everything. And these are what we're calling our distribution services, where we can basically, really drive the user experience to how our customers want it. And with that, we've also integrated with our data lake and analytics products across our product sets, meaning that we can react to customer changes in their financial world very quickly. We can also start to recommend what we're terming as financial well-being with our explainable AI. So it's not just about providing products and experience, but also to enhance that experience with mining the data that's coming out of all of those products, because that's where we see a lot of value as well.
Excellent. Thank you very much. Thank you, Wissam. So let me fast forward to the next topic that we'll quickly cover, and that is NuoDB database. We've mentioned that NuoDB database is cloud native by its design. And just to frame it for you, because clearly we can spend a lot of time on this, but conceptually it's very, very similar. most of you in this session, I'm sure you're familiar with the notion of traditional databases. Fantastic technology over many, many years from Oracle, IBM, Microsoft. Traditional databases tend to be centralized. That means that they've been designed to operate in a single host. And clearly that in a cloud environment, which is very dynamic, scale out is really the definition of what public cloud is, because you can bring in more resources on demand, and applications generally need to be able to take advantage of that. So this is the reason why we designed NuoDB in a very different way, right? So NuoDB on the right side, you can see, is delivering as a database the same kind of capabilities that you find in other traditional databases. And specifically, it's fully SQL compliant, and it delivers NC SQL implementation. And it's also transactional, right? Meaning that applications can run very sophisticated operational loads against this database and be confident that the operations such as account, deposits, withdrawals, account transfer, credit card payments, and so forth, that they reliably stored in the database. So clearly, that's the foundational capability. However, once you start looking at how NuoDB actually accomplishes these types of tasks, they're dramatically different from traditional databases. On the right side, you see that NuoDB is comprised of multiple database servers which work together as a single logical database. So this green bubbles on the right side represent server processes. The outcome of this type of architecture is very profound, and that's why we call it cloud native. It has been designed for distributed systems. It hasn't been designed to operate either in a public cloud or on-prem, but deliver this distributed system functionality. The first most important outcome of this approach is high availability, meaning that any of the servers can fail or multiple servers can fail, but the database service will continue to be delivered, right? So high availability is clearly critical, because as you can imagine, if you have an outage of some kind in a cloud, you don't want your bank to stop operating, right? The kinds of applications that need to operate in public cloud highly rely on this notion of high availability. So that's the first outcome, which is critical. The second outcome is this notion of horizontal scale out, right? Meaning that if for instance, you have some sort of a spike in processing, either something that the system was not anticipating or something that you're planning for instance, close of business processing, right? If that happens, the system needs to be able to react with a higher capacity than normally. In a public cloud, it's easy to add additional capacity by adding more servers. So this notion of scale out is very critical, both in terms of the kinds of systems you can address. So NuoDB can address very large transactional loads and throughputs successfully, right? And at the same time, it can also save consumers a lot of money, right? Because you don't have to over-provision the systems. You can just use as much as you need at any given time. And lastly, what's very important in this architecture, that it's active, 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 meaning that in traditional technology, you may have multiple databases deployed, but only one of them is actually active at any given time. In case of NuoDB, all servers that comprise the database are active, and therefore applications can connect to any of them, and they'll see the right view of the database, transactional view of the database, despite what server they connect to. All servers see the database in exactly the same consistent logical view. So between those three things, high availability, horizontal scale out, and active active, NuoDB is truly a cloud native database that provides these capabilities to the application Temenos platform, and therefore the whole stack, the whole solution is cloud native and can take advantage of underlying infrastructure in public cloud or private cloud in its fullest extent. So the next picture, and again, if somebody is interested, we can dive into this kind of details at a later follow-up. But I wanted, rather than go into the details of how database works, fast forward to a point, that's how database behaves, right? And that's probably the most important thing. So this particular graph illustrates a benchmark, a formal benchmark, which was actually done by Temenos. So it's not a contrived benchmark. It's actually the application, right? A core banking application running against the database. And you see two lines here. There is a red line and there's a green line. The red line depicts how a traditional database reacts to increasing workload. So increasing workload, in this case, you can see a number of digits on the bottom x-axis, illustrates how many application servers are operating against the database. And as you can see, as the numbers of servers increase, the traditional database ability to process transactions levels off, right? If we would continue to increase the number of servers, you would see that at some point in time, the actual workload will go down, right? It's a normal bell curve. However, if you take a look at the green line above that, that's how NuoDB responds to increasing workload. NuoDB can scale out, and therefore you can see that as the number of application servers or number of instances of applications that operate against the database increases, NuoDB reacts linearly, right? What this means is that as the load increases, the capacity can increase as well, resulting in very predictable scaled out capacity, which allows systems to either anticipate and prepare for certain workloads, like for instance close of business processing, or there is a peak in processing, for instance in credit card world. The holidays, New Year holidays are a big demand, right? In big demand. So you can prepare and anticipate this kind of capacity processing as you need to by allocating more resources. And this is a fundamental behavior that illustrates both the ability to process more transactions and also react to this dynamically. There are several aspects which this is critical for in a cloud environment. It first of all removes the ceiling of how large your system can be, right? And in the terms of in a banking terms, what it allows us to do is to address jointly with Temenos much larger organizations that can be moving their systems towards the public cloud. So, for instance, if in a traditional database world, the capacity, and I'm just throwing out certain numbers, right? If you can address, let's say, 5 to 10 million accounts in terms of the size of bank that can be processed in public cloud, with NuoDB and its scale-out capacity, a bank can be processing and servicing, hundreds of millions of accounts. And the infrastructure, both in terms of Temenos and in terms of the database, will be able to cope with this kind of scale. So with that, let's just put a placeholder that NuoDB is a cloud-native database technology that fits into the stack and allows you to address much bigger problems more efficiently or smaller problems more efficiently. So now let's move to the next step, and we'll share with you a couple of examples of banks around the globe taking advantage of this cloud-native capabilities in order to derive benefits from public or private cloud infrastructure. So the first example you can see here is a bank. This particular bank is in Hong Kong in Asia, and it deployed its operation against two public cloud providers, right? You can see on the right side that infrastructure is very simple, right? It's T24, which is one of the Temenos transaction processing products. It's a platform, banking platform, but you can see that it operates against the same logical database, NuoDB, but the database exists across two public clouds. So the data is replicated and it is redundant and exists in both of the clouds. Both clouds are active, and the bank is capable of operating against both sides. The benefit of this type of approach is high availability. So let's say that cloud service provider has an outage, and even though that doesn't happen often, but it happens, right? If you go back and you look at Microsoft, Amazon Web Services, or Google history, right? There are certain instances where there is global outage of service. It may not last long. It may last a couple of hours. It may last half an hour. It may last a day. But nevertheless, bank normally cannot operate. In this kind of environment that we're presenting here, the actual cloud provider can fail, but the bank will continue to operate. So from regulatory perspective, this represents a very important stepping stone that there's a term that is used quite often, concentration of risk, right? With a single cloud provider, the concentration of risk, if that cloud provider fails for whatever reason, is very large. Once you have two cloud providers, the concentration of risk that the bank will stop operating is much lower. And therefore, this is a really emerging, very important architecture, especially in Asia-Pac, where regulators are starting to enforce this type of deployment topology as the necessary step to start moving core banking operations towards the cloud. So a couple of other things on the bottom, several bullets here will give you other kinds of information about this particular customer deployment, which is quite impressive. One of the things that I've mentioned before is that normally you would think, well, it takes a long time to actually embrace cloud native and move my operations to the cloud. Not the case. Quite the opposite is true, right? So in this particular case, from step one to the point where the bank became operational, the entire process took less than 6 months, which is, in the banking terms, it's unheard of, right? The reason why that was to be able to happen is that Temenos provides very sophisticated core banking off-the-shelf package of operations and capabilities that banks can start working day one, right? And it's just a question of deploying this infrastructure, testing this infrastructure, customizing towards your specific needs, making sure it operates as you expect, and then it's open for business. So that's a huge step forward for how these types of organizations can roll their services out. The other thing we've mentioned, that multi-cloud regulatory requirement was easily satisfied with this kind of architecture in a unique way, right? There's no other implementation that could be able to actually fit in this kind of environment and take advantage of those two cloud providers in an active manner, which is very, very important. And lastly, as Wissam mentioned in his part of the presentation, that Temenos infrastructure is today all container-based. So this particular implementation is 100% container-based, from database to application to operations to management. It uses Kubernetes, and it uses a component which is called Rancher, which provides sort of coordination and all types of enterprise services for the Kubernetes infrastructure. But it's a great example of highly available, highly elastic system which exists across two public clouds and entirely implemented with containers and Kubernetes. So that's the first example. The second example is, let me fast forward to move to the next slide, is an opposite end of the spectrum, if you will. This is an organization that deploys today in a cloud-native form, but for on-prem, right? And this underlines one of our sort of best practices, if you will, that the cloud journey, the public cloud journey, needs to be able to take place on your time, right? What's important is how ready you are, what your regulatory and customer environment is, what is your current set of applications that you're operating, and how fast or slowly you can migrate with them. But this is an example of an organization which started its journey with private cloud on-prem, but with cloud-native stack, which is comprised of Temenos product for transaction processing, and NuoDB is underlying distributed database. But now it has the ability to start moving towards public cloud in multiple ways, right? So you can see on the right side, you can start on-prem, but then you can start taking advantage of the public cloud capabilities as you need to. So first of all, you can start moving Temenos processing in an elastic manner to the cloud by effectively, deploying some of the application service in the cloud and expanding into the cloud. Then the database servers can be moved to the cloud as well, and whether those are the service which do transaction processing or the service which actually store the data. So you can end up in a configuration that allows you to have a hybrid operation where system is active across both the on-prem configuration and cloud configuration, public cloud configuration. And this is actually what we want to show you as an example of system testing for this particular system, which exists in two environments. It exists in on-prem configuration and in a public cloud configuration in an active fashion, right? So I'll go through this diagrams in a minute, but before we dive there, let me just walk you through what is this environment and what are the types of characteristics this environment has. So this is a Temenos T24 application. T24 is a part of the Temenos transaction processing products, which does core banking. So this is a core banking application with NuoDB underneath as a database. It's deployed across two Anthos clusters. So Anthos is a Kubernetes version of infrastructure that is delivered by Google. It's very interesting, very innovative infrastructure which allows you to combine enterprise level services with open source Kubernetes. And we see a lot of activity around that in the banking space. And so in this particular case, we configured two clusters. One cluster exists on-prem and one cluster exists in the public cloud, GCP, right? So GCP is a Google Cloud platform. The types of operations that, if you just follow these bullets on the right side, the types of operations that this system actually is driving is retail banking operations. So you have deposits, you have withdrawals, you have transfers, the normal mix of operation in the kinds of inquiries and the kind of proportions that you would see from a fully functioning bank. Now, the interesting thing now, we'll go into this test scenarios set of points, is that, and it's very unique, that this particular setup allows a bank to be active across both on-prem and public cloud parts of the system. And that is very unique. Usually you have master, you have a primary and secondary. Sometimes you can read against secondary, but never in any of this configuration you have active. NuoDB allows you to have, together with T24 and Temenos, active parts of the bank. Now, the other very important aspect of the system, it can scale out on demand as needed. And you can configure, and we actually will see that you can configure your on-prem side to scale out differently than your cloud side. As we talked about, public cloud provides ability to really scale out, meaning adding more capacity as needed in an infinite way. So the policies that you may have your system configured with may have different policies for on-prem versus public cloud side of the deployment, and we'll see how that happens. And lastly, probably the most important foundational aspect of any kind of infrastructure is high availability. So we'll see in a minute, I'll walk you through a couple of evidence of that in this case, the most sort of radical way of failure, if either the on-prem side fails for whatever reason, right? Maybe some networking configuration, maybe you lost power to the data center. If that happens, the bank can still continue operating, maybe at a slightly reduced capacity, but nevertheless operating with public-only side. The same is true for public cloud side. If the public cloud side fails, the bank will still continue to operate with on-prem side of its operation. So then on the bottom, you can see in the middle there, towards the diagram, you can see a stack of technologies that are used in this particular implementation. This is Temenos, core banking system. It's NuoDB as a distributed database. It's Anthos as enterprise-level Kubernetes implementation. And Google Cloud is the public side of this deployment. The on-prem side is just a data center in which private cloud is configured with Kubernetes and Anthos. So now switching over to the left side of this slide, I just wanted to walk you through a couple of visual evidence, if you will, how the system operates. And I want to start maybe from the bottom up, if you will, right? So first of all, before we go bottom up, on the top, you can see inbound messages. So this is a messaging infrastructure. The way that the system reacts is by messages being introduced, requests, right? Requests come into the system. Requests may be inquiry, transfer, withdrawal, or deposit. These are the typical messages that come into the system, and you can see that the graph as the volume of messages is increasing over time as the system starts to operate in the higher capacity. Then, if you will, please let me switch to bullet number 1 towards the bottom. And here, let me just describe the diagram. On the left side of the diagram, towards the bottom, the boxes, diagrams 2, 3, and 4 on the left side describe the on-prem side of the installation, and the diagrams on the right side describe the cloud side version of the cloud side part of the system. Right. So if we go towards the bottom, what we've done in terms of the actual way that the test is going to be run, we actually are taking the on-prem side down, right? So you can see number one on-prem failure. You can see that somewhere after half an hour or so of operation, you can see the diagram yellow and green lines towards the bottom, and you can see the small text describing exactly what this is. This is committed transaction on the very bottom line, and before that, it's a CPU consumed by application. But you can see that at some point in time, we turn off the on-prem, right? The on-prem is off, but you can see that on the right side, what happens at the same time, that the workload increases because now on-prem side cannot process transactions anymore. But how does system react to this? Well, it reacts to it by increasing capacity and transaction rates, as you can see on the bottom. What the cloud essentially takes over and increases its capacity or its capability to process transaction. But the system operation continues, right? So that's the very important first step. The system on the right on-prem fails, but the system continues to operate. What happens next is extremely important. The on-prem side comes back up. Let's say the power is back, and now the data center is recovering and it's coming up. And you can see here that the system is automatically, and that's on-prem recovery bullet, automatically comes back up and starts processing data. And you can see that on the right side, in the public cloud side, over time, the system stabilizes, and the public cloud side of transaction processing actually starts going down, and at some point it stabilizes at the state it was before the failure occurred. So two very important takeaways, right? First, failures can happen, but this massive failures, like the whole on-prem side is gone, but the system will continue to operate. And the second, not less important point, when the system comes up, it automatically heals itself. It comes back up, it recovers. And for complex distributed systems, that's absolutely essential. That's what the system does. Now let's quickly go above this to bullet number 3, and I just wanted to show you this notion of how scale out happens. First of all, you can see multiple lines, right, as the workload increases. So for instance, the first arrow, the second arrow rather, on bullet 3 shows you that as system recovers, there's more load that is exerted on the system. So rather than having 2 servers, it has a bigger load. It scales out to 3 servers which are operating, right? These are 3 database servers. As you go towards the right side, you can see that on the right side in public cloud, we have scale out to many, many servers, both database and T24 Temenos, which are operating in exactly the same time, and they are the ones who are effectively splitting the load. But as the demand, processing demand increase, we have ability to start more servers, and that's what the system illustrates. So hopefully this is useful. It provides you a visual context for how these things actually put together and they're operating. And just recap again, high availability and recovery are critical, and scale out are critical. And in this particular case, this hybrid deployment across on-prem and public cloud delivers exactly that. So with this, we wanted to conclude this session. Hopefully it was useful in terms of defining a couple of concepts. We wanted to start with the notion that cloud native is the way to transition your existing core banking and other types of critical banking infrastructure towards public cloud. You cannot do it by lift and shift. You have to go to cloud native. And cloud native is not an easy step forward. It's not incremental. It's a dramatic change in how everything is done, how software is developed, how software is operated, what are the components, how software is built, and how it's architected. So unless you have the entire stack being cloud native, it's really a very difficult task. Good thing is that we have technologies like Temenos and NuoDB, which enable you to have cloud native solution out of the box, right? So you can deploy it yourself, you can operate it yourself. NuoDB and Temenos provide hand-holding technology transfer services, which will enable your staff to be fully up to speed and operate it themselves. or the entire stack can be delivered as a service, right? So it's sort of like bank as a service that you can just flip on, and in a matter of months or even weeks and days, it could be available for you to start processing your business transactions. So the last point is that if you decide that you want to operate it yourself, and you don't need to wait until you're ready to go to the public cloud, you can start on your own timeline. You can start moving towards cloud-native on-prem implementation at any point in time. And again, the same technology stack provides this kind of capabilities to the banking customers. So this is what we had for you prepared for today. Just a couple of next steps. We have a series of these webinars, these tech talks. This is an introductory one, but we have a number of talks which are hosted by Temenos and NuoDB and go into more detail around scalability, around other examples. We have a session with CTOs of several companies, a customer, Temenos and NuoDB, which is more of a discussion format. But nevertheless, the next webinar is in 1 week, and you can see the title here that, what more can you do with the cloud? It drills a little bit further into the kinds of capabilities that public cloud provides you with. As well, if you're interested, you can find on our website a white paper. Here it is, Visionary Financial Services, and how to move beyond multi-cloud, how to move to multi-cloud and inter-cloud operations. And lastly, if you're very hands-on and you want to take at least NuoDB technology out for a ride, you can do so with our community edition, which is freely available on our website. And it comes with all kinds of good instructions, and we're also available to help. So with that, why don't we move towards the questions?
Great. Thank you, Boris and Wissam. In the time remaining, we have some questions submitted for you, so I'll get started with this one. Boris, how does NuoDB compare to traditional database management systems such as Oracle?
So thank you, Sam. So great question. We've touched on that a little bit, but effectively, again, I can't overemphasize. I'm an old Oracle developer, and I love the technology, use it for many, many years. Great technologies. However, it was developed 40 years ago for a very different class of problem. With the emergence of this cloud-native architectures, what traditional databases like Oracle don't have is ability to begin with scale out, right? Therefore, add more capacity by adding more servers. This kind of capability actually in Oracle exists for on-prem deployments as Exadata or Oracle RAC. This configuration is not available in the public cloud. So all those systems which today depend on these types of high fidelity infrastructure would have to rethink how to do the same thing, how to accomplish the same kind of qualities of service in the cloud. That's what NuoDB does. It's been specifically designed to achieve the kinds of things that Exadata and RAC do in a public setting, in a private setting environment, to do the same thing in the public cloud or private cloud.
Awesome. The next question is for Wissam. Can digital banking solutions really handle all of the transactions of an enterprise bank, or is it really best for challenger banks?
Well, I mean, the question there really is about scalability, and yeah, we can, Temenos and NuoDB can serve any financial institution, large or small. What is key is how the solution scales. I mean, Temenos is an online transaction processing system. We want to be able to take the workload as fast as possible and give the responses. Now, traditionally, what's happened with workloads is you always had to size for the maximum peak expected workload, and down to the database as well. And with traditional databases, I mean, Temenos is quite I/O bound. You would have to put a bigger and bigger server just sitting there waiting for the for various for the max workload. So as workloads have become very unpredictable, we need to have a fully elastically scalable solution. So not only does Temenos Transact scale up as the workload increases, but also the database, which NuoDB does. And and then back down when you don't need a workload. So yeah, we can completely satisfy any workload at all.
Boris, this one's for you. Are there any particular types of financial services applications that NuoDB as a distributed SQL database is good for?
Great question. Thank you, Sam. So if we look at the Temenos offering, right, it becomes clear that probably the most natural workload and application for NuoDB is something that is really OLTP or transaction processing intensive. So and therefore core banking processing, payments, transaction-oriented processing is something that NuoDB is really the best in. But also there are other applications in the context of finance, which may be a little bit counterintuitive, but NuoDB is very good at. Something we haven't talked about, NuoDB is a memory-centric database, and therefore it can, for the types of applications which can take advantage of data residing in memory, can be very good. So transaction processing is one of them, but there are other applications like, for instance, clearly credit card processing is another example of OLTP, but things that deal, for instance, with financial crime, where and analytics, where a lot of data can be residing in memory of quite a few machines, but then you get instant access to this data for all kinds of algorithms and ability to process very large data sets at in-memory speeds that dramatically improves. We have a couple of applications outside of Temenos deployed in a number of tier 1 and tier 2 banks, which deal exactly with that class of problem, sort of financial crime, in-memory analytics, and that would be another way to leverage technology to solve these types of problems.
Okay, and then I think we have time for one final question. If we don't get to your question, we'll reach out via email with the response for you. But this one's for Wissam. Have you seen a large initiative for customers moving to the cloud?
Yeah, great question. So, I mean, I speak to many clients, mainly Europe, Northern Europe, and each have, got different views on cloud adoption and everything. And some are more along the cloud journey than others. But the common theme across all of the clients that I speak to, basically they want to have a future-proof solution. They want to have a solution in place. Whatever they buy right now or deploy right now has to be cloud native. There is no choice. You're going to put a core banking system in. It's going to be at least 10 years before you're going to refresh that whole technology stack. So, and the cloud is inevitable, and they see that. It's a fact of life. It's the only way you're going to be able to compete in this industry is by reducing your operational costs, etc. And so it's almost like a no-brainer. We have to suggest, we have to to deploy all the components of a system that can not just do a classic lift and shift, but to really utilize the cloud infrastructure as efficiently as possible, and also the capability to be able to provide active from on-prem to cloud, as Boris said, or from one cloud provider to another, is a completely game changer for a lot of the banks. So yeah, there's a big interest out there, and watch this space. It will definitely happen.
Great. Thank you both. That's all the time we have for today. Thank you to our presentations for our presenters for the great presentations, and thanks to our audience for attending today. Please visit nuodb.com for more information, and be sure to attend our next webinar in the series, Do More Clouds Equal Better Scalability, Availability, and Flexibility? Thank you again for attending. This concludes today's webinar.